Okay, greetings students. This is going to be a video on how to solve the problem in test 3. So it's basically a cantilever beam with a UDL. It's fixed on one side to a wall. It's supported by a roller support on the other side. There is a UDL that is running across the beam. Information is given in terms of a reaction moment at one side and an angle, a rotational angle at a distance of 1/3 of the length. Using that information, it asks to solve for the beam length, the UDL, the maximum beam deflection, beam rotation at one side, and a beam deflection at the point of inflection. So let's go ahead and solve the problem. So let's do it. There was only one question, but of course there were different components to the question. So we've got a beam of a certain length, whatever the length is. So that is the beam. It is fixed to a wall. There is a UDL across the entire length of the beam, and it is supported on its end by a roller pin support. So this is the UDL of the beam, constant UDL. We'll call the point on the left hand side A, point on the right hand side B. There is a coordinate system, an XY coordinate system, centered at the point A. There's a simple roller support, so there'd be a reaction force, and at the wall there would also be a reaction force and a reaction moment, and the total length is L, and somewhere along the length of the beam theta at that point is given, and I've also known the reaction force. So what we do is we apply the equilibrium equations. Sum of vertical forces is 0. So we choose a sign convention, positive x to the right, positive y upwards, positive angles anti-clockwise. Apply equilibrium. Odd A is assumed positive, odd B is assumed positive, the UDL is going downwards. Q times L will give you a force. Add up the moments, make things easy. Sum of moments at point A is 0. MA is there. Odd A doesn't contribute anything. Anti-clockwise, odd B. And then the UDL would be in the clockwise direction. Now, I can then solve for all of the other reactions in terms of MA, so it will follow that odd B is equal to, just solve and rearrange from this equation, a half QL squared divided by L, which is a half QL minus MA of L. And then odd B would be QL minus odd B, so odd A is equal to QL minus a half QL, which is a half QL, and then plus MA over L. Now I can work out the bending moment by taking cuts on the system. So we've got our beam, we've got the UDL, this is just a free body, so we're only going to look at the forces. We've got a moment, we've got our point where we took the cut, we've got a shear force on both sides, we've got a reaction moment on the one side, we've got a reaction force, we've got the rest of the beam where we took the cut, we've got the UDL, and we've got the reaction force. And of course the distance from the wall to where we took the cut is x, and by implication the remaining distance is L minus x. We apply equilibrium of moments. We can look on the left or we can look on the right. Let's look on the left. So I will have bending moment M in an anti-clockwise direction. Shear force doesn't contribute anything. The reaction moment is constant. It will travel along the beam in an anti-clockwise direction. And the UDL would also be concentrated in the middle, pushing down over here, distance of half x, so it'll be anti-clockwise. And the reaction force would be in a clockwise. Rearranging the equation, over there I've already worked out odd A, so I can just substitute. That's the bending moment. Then I can substitute it into the flexural equation. Okay, I can integrate it. Okay, carrying on. So C1 is a constant, integrate it a second time. C2 is another constant. Now I can apply the boundary conditions to my equation in order to work out C1 and C2. What are the boundary conditions? The deflection at point A is 0, the slope at point A is 0, the deflection at point B is 0. So let's go ahead and try and solve it. So let's look at the first equation. The deflection at A is 0, so V0 EI times 0 is 0, so that will give me 0 is equal to, putting x is equal to 0 into my equation, gives me C2 0. Putting in the slope at 0, using the equation EI V primed, all of that stuff, and putting x is equal to 0 would give me C1 is 0. And then putting in a deflection of 0 at x is equal to L, that would give me 0 is equal to and I've already worked out C1 is 0 and C2 is 0. So that is my equation. I can simplify the equation a little bit by solving for MA in terms of, I guess, Q and L. So let's substitute it and see what happens. So that would then be six times 2 is 12. And 1/6. Okay. And then that would then be equal to -1/2 plus 1/6. Just going to use the calculator. So -1/2 plus 1/6. That's -1/3. And -1/24 plus 1/12. Which is plus 1/24. QL to the 4th power. And then just rearranging it, 1/3 MA is equal to 1/24 QL squared. And then just solving for MA. MA is equal to 3/24, which is 1/8 QL squared. And there we go. So that is the reaction force in terms of the load and the length. Now, what else do I need to do? I've solved for the constants, so it implies that beam deflection is going to be, my equation is EIV is equal to minus 1/2 MAX squared minus 1/24 QX to the 4th power plus 1/6 into 1/2 QL plus MA/L x cubed. So that's the beam deflection, and it also implies that the beam slope is equal to what we worked out as follows. Okay, that's our solution. Now we just have to process this and then work out what else we need to solve the problem. So the problem is specifying everything in terms of the reaction moment, and our equations is in terms of the reaction moment, and we were given information in terms of 1/3 of the length. So let's work out the slope at 1/3 of the length. So EI theta at x is equal to L/3, just putting in x is equal to 1/3 into this equation, that will give me MA 1/3 minus 1/6 Q L/3 cubed plus 1/2. Just put in the rest of the information. So equation, substitute, just simplify with the calculator. Minus 1/3 MA/L, 3 minus 1/6 into L/3 cubed. Again, we'll have to use the calculator. So 3 cubed is 3 times 3 times 3, which is 27. 27 times 6, which is 162. QL cubed, and then 3 squared is 9. 9 times 2, 3 squared is 9. 9 times 2 is 18. 18 times 2 is 36. QL something is not quite right over here. Our gradient EI is minus MAX minus 1/6 QX cubed plus 1/2 QL plus MA/L x squared. I've got an MA/L, I've got a QX cubed, I've got a QL cubed. Yep, so this is that plus 1/36 QL cubed. It is right. And so 3 squared is 9. 9 times 2 is 18. 18 times 2 is 36. 1/36 QL cubed plus 3 times 3 is 9. 9 times 2 is 18 plus 1/18 MAL. Yep, that looks consistent. So minus 1/3 plus 1 over 18. So minus 1/3 plus 1 over 18. Which is minus 5 over 18. And then minus 1 over 62 plus 1 over 36. Okay. So that apparently is the answer. So what else do I do with that? Okay. So we have EI is F, theta, which is equal to minus 5 over 18 MAL plus 7 over 324 QL cubed. And what do? We put in our value of MA. So this is minus 5 over 18, 1 over 8 QL squared times L plus 7 over 324 QL cubed. We just then simplify it. If theta is equal to 18 times 8, 18 times 8 is going to give me some answer. So 5 over 18 times 1 over 8, 5 over 18 times 5 over 18 times 1 over 8, which is 5 minus 5 over 144 QL cubed plus 7 over 324 QL cubed. I've got a QL cubed and a QL cubed. I can just work it out from the calculator. So this is minus 5 over 144 plus 7 over 324, which is minus 17 over 1296 QL cubed. Okay. Okay, and then just divide by the flexural rigidity. So theta is then going to give me minus 17 over 1296 QL cubed over F. Okay, I think that looks good. Call this page 1. So we have calculated theta is minus 17 over 1296 QL cubed over F. That's what we have. And the question is asking us for the beam length, the UDL, the magnitudes and stuff. So for question 1, we want to work out the beam length. So this is page 1, we'll call this page 2. Let's just write our equation and see what we have. So the equation is theta is equal to minus 17 over 1296 QL cubed over F. So we then have to do some calculations. But remember, we've already worked out MA is 1/8 QL squared. 1/8 QL squared. So we can just as well put the MA into that. Well, this would imply QL squared is equal to 8 MA. So this would then be QL cubed is QL squared times L. So just put in the QL, put in another L, and then put the F. And then I guess you would have to 17 times 8. So with our calculator, we would have to work out 17 times 8, which is 136. So this would be minus 136 over 1296 MAL over F. Let's see if we can simplify 136 over 1296. It simplifies to that, so that is minus 17 over 162 MAL over F. Okay. So our equation is theta is equal to minus 17 over 162 MAL over F. This is our equation that we're going to use now to solve everything. Alright, so we want to work out what we want to work out. The length, the UDL, the beam deflection, and other stuff. So let's start with the beam length. The beam length, we're just going to rearrange the equation. It follows that L is equal to minus 162 over 17 theta times F over MA, which is equal to minus 162 over 17 F theta over MA. So L is equal to minus 162 over 17 times, and in my case the value of F is 1.0 blah blah blah. The MA is that. I'm just going to put it into the equation 1.0400324 times 10 to the 4. Theta is apparently 24.2 207.2654, 207.2654 divided by I substituted wrong. Theta is equal to minus 162 over 17 f theta over ma, which is equal to minus 162 over 17 into f, which is 1.04000324 times 10 to the 4. That's f. Theta is minus 2.04404523 times 10 to the minus 4 divided by ma, which is 24.20726524. And I just work it out with the calculator. This is why I said you can use Excel or computer. So in my case, I'm not going to use the computer. I'm just going to work it out with the calculator. So minus 162 divided by 17, which is that, multiply by 1.04000324 exponent 4 times minus 2.04404523 exponent minus 4 equals divided by 24.20726 and in my case this is the length, 0.8368, 0.836869 489. Okay, so this is the length in meters, and the question said you must put it to 8 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 decimal places. So I would type this entire numbers into the website. Now I must work out the magnitude of the UDL, in other words the value of Q. So I've got the angle theta in terms of the UDL, the length and everything. So I can just as well rearrange this equation. Remember, I've got the theta, I've got the F, the flexural rigidity, I've just worked out the length, then I can work out the Q. So we'll just rearrange the equation. We have theta is equal to minus 17 over 1296 QL cubed over F. So this would imply Q is equal to minus 1296 over 17 multiplying by F theta over L cubed. So Q is equal to minus 1296 over 17 times F. F is from my question, the 1.04 and change. So this would be, I guess, 1.04000324 times 10 to the 4 times theta, which is minus 2.04404523 times 10 to the minus 4 divided by L cubed, which is 0.836869489 cubed. Okay, so let's use the calculator. So I'm going to first cube the thing, 0.836869,489 cubed, which is that number. Take the reciprocal of that, get an answer, and then times all of the other stuff. So times 1.0400324 exponent 4 times minus 2.04404.523 exponent minus 4, get an answer, times minus 1296 over that.